Hello and welcome to Eliminating the Problem of Inaccurate Precision Weighing Measurements Caused by Static Charge, presented by American Laboratory and sponsored by NRD Advanced Static Control. This is Steve Ernst, editor of American Laboratory and moderator for today's presentation. During the presentation, 3 polling questions will be asked, and we will report back to you the level of audience awareness of the problems and solutions related to environmental static electricity. There will also be a live Q&A session at the end of the presentation. Questions can be submitted at any time using the Q&A button on the screen. Also on the screen, please note the resource box, which contains documents offering further information related to today's topic. Today's speaker is Greg Gumkowski. He's the National Sales Manager for NRD Advanced Static Control. He has worked in the static control market for more than 13 years. Holding degrees in material science and engineering metallurgy, Greg is a member of the Electrostatic Discharge, or ESD Association, and is a certified ESD technician. Welcome, Greg.
Thank you, Steve. Thank you, everybody, for attending this presentation, and I appreciate the opportunity to speak on such an important topic. The topics I'd like to go over today include industry awareness, a little bit about the basics of how static is generated and removed, how static affects precision weighing, the different types of controlling methodologies that can be employed, and then look at a couple different applications that people might be familiar with and how we could address those. This slide pertains to just the fact that, in the summary view of different periodicals out in the industry, this topic is relevant, it is prevalent, from American Laboratory to Lab Manager. And recently, one of the manufacturers put out a very interesting white paper. And what was very surprising to someone who doesn't actually participate in the industry, to see how high the error level could be if static control or static charges aren't controlled. So now we'd like to talk a little bit about the basics of what static is and how it can affect things.
And before we start with that, we have our first polling question. We'd like to know of the attendees today, are you very familiar, somewhat familiar, or not at all familiar with the causes of static discharge and how it can affect precision weighing accuracy? Please input your answer by clicking on the button next to your selection and hitting submit on your screen. You'll have 5 seconds to do so. It looks like the big majority of the audience, over 70%, are somewhat familiar. So, Greg, I think you have a group here that's ready to learn.
That's terrific. It's good to know that the audience has a basic understanding, and hopefully as we go through the next few slides, it'll enrich that understanding. So looking at this particular slide, what we see is static charge is a function of motion. It's either friction, two things rubbing against each other, similar to, say, shuffling your feet on the carpet and then going to reach for a doorknob, where you get a static charge, or contact and separation. An example of this would be that roll of Scotch tape. You try to pull off a long piece of it, and it curls up on itself. Now, once that static charge is generated, there are 2 basic effects that happen because of that. An electrostatic field is generated, and that electrostatic field does have a force component to it. And we'll see as we move into the presentation how those 2 items affect your ability to get accurate measurement. So when we talk about contact and separation, there is a whole field of study surrounding that. It's called triboelectric charging. And anytime you take 2 materials that are dissimilar, you put them in intimate contact with each other and separate, there'll be an electron exchange. One of the materials will charge positive and the other will charge negative. After much study and research, an actual chart was developed that ranks the different types of materials that we encounter in our daily lives or in the laboratory as to how do they tend to charge. So as you look to the top of the chart, you'll see items that tend to charge positively. The things at the bottom of the chart tend to charge negatively. The further apart they are on the chart, the much stronger static charge will be developed. And at this point, before we move to the next slide, there is one other thing that's important to mention, and that there are basically two classes of materials as you look at everything on the chart. One class are materials that are considered conductors. Conductors allow static charge to freely flow back and forth across it. Conductors can be grounded and drain the charge away. The other class would be that of insulators. Insulators do not allow you to have the charge drain away. It's stuck on the surface, and it presents a unique set of challenges. So what types of factors affect triboelectric charging? Condition of the two surfaces. The rougher they are, the less intimate contact you have, so the less charging that'll happen. The size of the areas that are coming in contact with each other and separating. Smaller areas, less charge, larger areas, greater charge. The pressure applied to the two surfaces as they're coming in contact and being separated. Again, similarly, less contact, less pressure, less charging. The speed of separation, if you remove them very rapidly, you're going to develop a very large charge. And lastly, the amount of humidity in the air. And as many of us know, in the wintertime, when it's dry out, everything is staticky. In the summertime, as humidity levels rise, there's less static because the moisture in the air has what's called an ionic component to it, and it actually drains the charge away to the moisture in the air. Now, there's a special class. Now, I previously mentioned in the other slide that conductors have the ability to drain charge. But that means they have to come in contact with a larger object that can accept that charge or ground. But if the conductor is isolated from ground, it will hold its charge. Why this is important in analytical weighing, precision weighing, is that the balance pan, which is stainless steel, is isolated from ground. So the pan itself can hold a static charge, and it's got nowhere to drain, and that will cause issues with the ability to have an accurate measurement. So now we'd like to move into an area that we talk about how do these static charges actually affect precision weighing. So again, we see our static charge. It has a field component and a force component. The field component will attract particulate or cause repulsion of particulate out of the surrounding area. So people who are weighing fine powders will often comment about how the powder seems to jump out of the vial. But if you have a strong charge on, say, a filter paper, you could also potentially attract outside particulate to it. With regard to electrostatic force, this actually causes small movements in objects. In particular, in the subject we're talking about, it's actually causing the weigh pan to move. This next slide, although in a different industry, gives a very good visual interpretation of what's going on. What we see in the lower left-hand corner, it's a silicon wafer used for making semiconductor in a clean room environment with a downdraft type situation. So there's particulate in the air, and it's meant to flow over things, but you can still see there's a small amount of particulate that's accumulating on there. Now when we move to the slide on the right, this is the exact same wafer in the exact same environment over the exact same time, the only difference being it has a small voltage, static voltage applied to it. And in that same period of time, it attracted 7 times the amount of particles. This is not something that we would want to see when we're trying to do very finite measurements on filter papers and samples. In this slide, we're talking about the effect of static charge and causing movement on the weigh pan. Now, you can have static charges on the weigh chamber itself or the objects you're placing in. Here in this photo, you can see a filter paper that has a static charge on it. It's being held within an inch of the plate, and it's interacting. It's causing a charge. We called it the isolated conductor in the plate, and it's lifting the plate up, and you can see how the measurement has changed due to that, and that will cause inaccuracies in zeroing and getting repeatability in your measurements. The next thing we'd like to talk about is we know there's an issue. We've seen the different types of ways it affects the scale. So what types of things can we do to control the static? And here we have another poll question.
Our second polling question today regards the type of static control currently being used. The choices are a balance equipped with a built-in static eliminator, purchase and use an aftermarket product such as an anti-static gun, blower, or ionizing strip, piezoelectric gun, other, or do not currently use static control devices. And we'll leave 5 seconds for answers.
Steve, I'd like to make one quick comment as they're looking at these choices. People may not be familiar with the term a piezoelectric gun. What I'm referring to here, through talking with a lot of people in the field, there is a red-handled squeeze gun that many people use. It's called a zero-stat gun. So that's the object I'm talking about there when you're making your selections.
A zero-stat gun, is that?
A zero-stat gun is what it's called. It has a red handle, and many technicians might be familiar with it.
And it looks like the results, most people use an aftermarket product with the small amounts using piezoelectric guns, built-in eliminators, or other. So almost half the audience is using the anti-static gun, blower, or ionizing strip.
Very good. That's excellent to see in here. What we have to do is we have to help encourage those people who aren't using any form of static control, and hopefully by the time we finish today, they'll see the value in doing that. So moving on to the slide on methods of static control, there's 3 basic methods. There's grounding of work areas and the personnel themselves, trying to control the materials that you're using in the process. We call them sometimes process-required insulators, but there's other types of materials that might be better suited. And then if you have to use insulators, then you're going to have to take a look at utilizing ionization to get rid of that static charge. So in this slide, we're talking about grounding. Most importantly, the operator. Although we as human beings are very conductive, typically we're wearing insulative shoes, so any charge that develops on us, especially in drier environments, as soon as we come in contact with the samples, the weighing materials, the weigh boats, the spatulas, even the weigh chamber itself will induce static charge on those things. So one of the things that we can do is wear a wrist strap, which will drain any static charge from us off into a groundable system. And here we see a workstation. On that workstation, there would probably be what we call an ESD-safe work mat, a common point ground where everything is connected together, and then that would be plugged into the facility's earth ground system. And we'll talk a little bit more about that too as well as we move forward. Material selection is important. We want to try to eliminate insulators if we can. There's a lot of other choices out there. Many materials, they add carbon or metal particulate to make it more conductive. They may add materials that help it attract humidity to it. And if possible, we can, for instance, in a smock or a lab coat, we want to use natural cotton fibers as opposed to synthetic. Other things that can be, sometimes they're topical treatments, there's sprays and things that can be used on the floor to reduce friction and things like that. And then the potential of using air ionization. So when we're talking about air ionization, using ionized air, it's actually putting a charge on the air molecules. So the air surrounding the work area does have a charge to it. So if we look at the bottom, we see a blue strip that's called an insulator. Now, it is either going to charge positively or negatively. And if we think about magnets, opposites attract. So on the left side of the bar, it has a positive charge. So it will attract all the negatively charged air molecules to the surface. On the right side, we have an example of something that's negatively charged. And similarly, it pulls all the positively charged ionized air to the surface. When the two come in contact, they exchange electrons, free electrons. Everybody's satisfied, the process stops, and we've neutralized our static charge. The key in doing air ionization is that we want to be able to make sure that we have equal numbers of these positive and negative ions there. We don't want to be shifted one way or the other, so we know we're doing very good neutralization of our surface. So as we talk about different types of air ionizers, one type of ionizer that's available in the industry is a nuclear or an alpha ionizer. Now, it uses a material called polonium-210 to ionize the air. It's a very safe product. It utilizes, if anyone's ever seen one, there's a strip of gold foil on the inside. That gold foil is considered with a sealed source. So we don't have to have concern about coming in contact with the raw material that's inside. It offers very balanced ionization. In most cases, it requires no power. If you're using it with the fan, obviously the fan would have to be plugged in. It does have a effective life to it, and in some places there are some regulations that have to be followed in order to use them and ship and return them. Our next slide actually shows an example of an alpha ionizer. So if you look at the back of the balance we have here, you see an ionizer position there. That is the appropriate place to put it. Now, an alpha ionizer, because it doesn't have a power source to it, it creates what we call local ionization. So you can see where the technician is bringing the sample closer to the ionizer. You'll also notice, if you look closely, there's a very fine braided wire connected to that. That is a ground wire. That is connected in our system to a common point ground. You don't have to use the ground, but we highly recommend that. The numbers sound astronomical sometimes, but by attaching that ground, it increases the performance of that ionizer 500%. So it's definitely worth adding that little wire to it. And obviously, these are very easily installed in a balance. Another type of ionizer that's commonly found is called a corona discharge ionizer. Now, this type of ionizer uses a power supply. It applies a high voltage, usually in excess of 5,000 volts, to sharp points or wires in the device itself. And that high voltage on those points or wires creates a very strong energy field, which actually strips electrons from the surrounding air, and that's how we get the ionized air. There's different types of corona discharge ionizers. There's AC, steady state DC, and pulse DC. We don't have the time today to get into each individual type, but they're all equally well-versed in the application. Here we see an example of a corona bar ionizer. It's that black strip sitting towards the back. Now, because this is a powered device, it extends its ion field further away from the bars. So if you could imagine in your mind an ion cloud, a static removal cloud, maybe the size of a cantaloupe, a large grapefruit extending beyond that. So anything that's passed through that field as it goes into the chamber, it will remove the static charge from it. When selecting an ionizer of this type, there's several things that are important to be aware of. One, you want to make sure that those emitter points, those stainless steel points or wires, are recessed in the device so you don't have a puncture hazard or you'll snag anything on it. You want an ionizer that has what's called a shielded power cable, so you don't have electrical noise interfering with your sensitive electronics in your balance. And lastly, you would like something that we consider to be shockless, that if an operator accidentally grabs or touches it while it's in operation, they will not get an electrical shock from it. Next, I'd like to talk about this because I think there's a lot of misunderstanding of what this device is, and it really doesn't, in my opinion, belong in this particular application. It's a piezoelectronic ionizer, and what you're seeing in this particular slide is a laboratory test setup to gauge its effectiveness. When we use an ionizer, as I've said before, we want it to be very balanced. We want to make sure that it doesn't leave any charge. So how this operates, when you squeeze the handle, it creates positive ions. Now, if you look in the upper right-hand side, you see the chart that records the charge. So it goes from 0 up 1,000 volts. So it's actually putting 1,000 volts of static charge on that plate. Releasing the handle creates negative ions. Now, ideally, you want to create the exact same number of negative ions so it returns to 0. But what you can see here is that it has dropped down past 0 to 1,000 volts negative. What that means is that after squeezing and releasing that handle, you are going to leave 1,000 volts of static charge on your samples and on your materials. Now, if you know that the material you're using always charges positive, then you would probably have decent results with this gun because it's always going to try to charge it negatively, and hopefully it's going to offset each other. But if you're using material that charges negatively, you're actually making the situation worse. And this is an uncontrolled device. There's really no way to squeeze it fast or slow or partially or 3 times to try to get it back to 0. It always charges negatively. So I just want to put that warning out there for the people using this. If you're seeing spotty results, that's the reason why. So in review, static charge generation is really unavoidable as long as there's things that are moving and we're using process-type insulators in our process. We can prove that static charge causes weighing equipment inaccuracies, unwanted transfer of particles during the weighing operation, and material transport. The good news is there are well-established methods of controlling that static charge. Insulating materials that are unavoidable, samples, transport holders, beakers, spatulas, weigh boats, those types of things, if they have to be used, then the appropriate air ionizer can be effectively used to eliminate static charge from those various items in your process. So at this point, I'd like to share a couple different examples that you might incur and what a solution might be. But before we do that, we have another poll question for Steve.
Our final polling question for today is, are you currently using Static Master ionizing cartridges for static elimination? Choices are yes, yes, but I'm not sure they're being used properly, or no, do not currently use. And we'll take a few seconds for those to be answered. And meanwhile, I'll remind you all, if you have questions for Greg, the Q&A tab at the bottom of your screen, click on that, and you can key in your question there. We'll answer them at the end of today's presentation. and I jumped too far. Almost 90% no, do not currently use. Just a few users out there, about 10%, Mike. So back to you.
All righty. So the reason for that question was many times in working with customers or at trade shows, people use them, but they're not sure about the proper use. And if we had a large portion of the audience that had that, I'd want to spend some more time talking about the proper use. But you'll see some example on the next few slides. So the first example we'll talk about, the situation would be, okay, I have a specimen on some filter paper that I need to be precisely weighed. The static charge on the filter paper can attract airborne contaminants. It can induce charges on the weigh pan, and it can create errors in the measurement. So what is a potential solution? The solution would be to remove any potential static charge, and that can be done in one of two places. It can be done prior to entering into the weigh chamber, or actually within the weigh chamber. So our next slide shows that particular type of a setup. Here we see on the left what's called a dual stat ionizer. It does use those static master cartridges. It's a nice product for this particular application because it ionizes both the top and the bottom of the filter at the same time before it goes into the chamber. The example on the right is a single ionizer. You can see that because it's only a single, we do have a grounding system for it to intensify the field. The important thing to note here is if you were doing a filter paper, you obviously would have to flip the filter paper over. Another thing that shouldn't be lost on this is that we want this holistic approach. So if I'm taking that sample and putting it on the weigh pan on top of a filter paper and a weigh boat on some other medium there, I want to make sure that there's no static charge on that before I put the filter on there so I know that I'm truly zeroed. You'll also notice below the pictures that there are links to videos that can be accessed after the presentation out of the resource location of the site here. In the next one here, we see just the different components of what you were looking at before. A very small ionizing cartridge. It's hard to tell scale on this. It's about 3 inches long, about 1 inch wide. There are nice holders that permanently mount into the balance, so they're easy to install. And below that you see the grounding system that is really essential in using the different types of cartridges like this. In our next example, static charges on weigh boats, filter papers, vials, beakers, test tubes, other specimen holders can induce charges in the specimen as well as into the weigh pan. The static charges can be on the exterior and interior surfaces of the specimen holder. So what would be the best way to handle this? The easiest would be an ionizing blower that will quickly and efficiently remove the charges on all the surfaces. So if we move in here, we can see a very small ionizing blower. To simplify its use, it has a temporary on-off, so it stays on for 15 seconds because many operators who stay at a balance all day long don't like the fan blowing on them, so it just turns on momentarily. Another nice thing about the small platform is, as I mentioned, a person wearing a synthetic material or a charge on them can actually induce charges on the weigh chamber, the acrylic or the glass walls, which will have an effect. So you can simply pick up this fan and ionize the inside and the outside of the weigh chamber itself to make sure it isn't inducing forces on your weigh pan. Our next situation, a single source solution that can eliminate static charges from powders, filters, specimen holders. Is there, instead of having all these different things, is there one that works relatively well for a variety of applications? In this case, I think using a single bar ionizer, Corona ionizer, is a really good solution because it doesn't require air to move, so it's not going to blow away fine powders or things when you're using it. Our next slide actually shows a sample of that bar ionizer. Here, taking the static off of a sample holder, handling it is going to put a charge on the outside. So you just be sure that you rotate it as it's going through the field. If I didn't have a cover on it, I'd want to hold it facing towards the bar to make sure those ions travel inside to it. And now I know my specimen holder is static free before I set it on my balance chamber. And many times in talking with end users, they'll comment to me that, yeah, I'll take in that weigh boat or whatever, and as I'm going to place it on the pan, I can see the numbers changing on my scale. I know it's influencing it. And what this is going to do, if the pan is being pulled up, you're trying to tar it out, you're thinking you're getting back to zero, but you're really not getting back to zero. You're trying to offset the effect of the static charge pulling the pan or pushing on the pan. And depending on the humidity in the air, you could start seeing drift on your zero because the static charge is going away and now it's not pulling as hard. Or worse, you think you've zeroed it, you're doing dosing of some kind of a medical powder, you think you have a couple of milligrams there and you actually don't. So mitigating these charges can be very critical in measurement. And our last example here, when working with very precise measurements, moving static charge from laboratory technicians is essential. Static charges on them or their clothing can be transferred to the specimens in the weigh chamber just by coming near them. So what would be recommended is setting up, if you have a particular station in your lab, you're doing, you're measuring out 5 and 6 places, 4 places, it's critical, you would want to have an ESD workstation set up for that particular location. And when I talk about a workstation, here are the components to that. You would have an ESD static dissipative mat that you would be you're placing your samples on, your balance on. You would be using a wrist strap. You'd be using cloth garments, and all of these things are connected in common at the back of the mat, and then the mat itself is connected into the facility ground. So that is our last example of typical applications.
Thanks very much, Greg. That was a lot of great information there. Looks like we have maybe a dozen or more questions from the audience, and we can start taking those now if you're set.
Yep.
First question. I recently realized that wearing gloves was causing a significant error in my measurement results. Everything I've been taught about using balances has emphasized wearing gloves and never once mentioned static issues. Why is this?
When you're wearing gloves, such as neoprene gloves, they are insulative. So as you're handling things, those gloves will start to charge up. And now anything you touch or handle, you're going to transfer the charge to that. If you have to do that, I would put on my gloves first, and then before I do my measurement, using something like that small blower that we had shown in a previous slide. I'm going to go back to that one just to show you what I'm talking about. So I would just put my hands in front of the fan for a moment or two, which would take all the static off of the gloves for that particular application, and then I would do my weighing. But you have to understand that once static's gone doesn't mean it stays gone. It's a function of friction, as we said. So continually to do things, if you have to wear gloves, that's a process insulator. There are some companies that talk about in the electronics area where they do have some materials. They tend to be more expensive. But just putting your hands in front of an ionizing blower would help with that situation. But wearing a wrist strap won't drain it off the glove. It'll drain it off the person, but not off the glove. Hopefully I answered that question.
Thanks, Greg. Next question is, how fast does the bar ionizer neutralize the static charge? Instantaneous, or does it take a few seconds?
That is the question that is the $6 million question. And the answer in static control is always and always, it depends. It depends on the materials, the size of the object, the humidity in the air, but in general, the size of the materials we're working on, just a few moments in front of an ionizing blower or a bar is more than sufficient to take the charge off. If I had a large glass beaker I grab it and I can feel the hair standing on my hand, on its end, you might want to spend more than maybe 10, 15 seconds in front of an ionizing blower. But that would be on the extreme side. A couple of seconds should be more than fine.
All right, next is, can a humidifier alone be an effective static charge controlling device?
Again, it depends. To get the humidity high enough to affect all the materials typically will not happen in a laboratory setting. You're talking about getting above 45%, close to 50% relative humidity. And all that's going to do is allow the charge to drain more quickly. But there are some process insulators that are really, really stubborn. Is it a good mitigation? It is something that can be done, and it is used. And you would have to monitor your results with that. And if you pull a weigh boat out of the package in your high humidity area and you have time to wait a minute or so, and then you place it over your weigh pan, and if you don't notice any movement in your weigh pan, I guess your humidity level is high enough in your particular situation. But if you see any movement at all in that weigh pan, indicated by a reading on the scale, then the humidity level isn't sufficient in and of itself.
All right, great. Next, how does the static mat work if you have an analytical balance on marble?
The reason I like to use the mat is that if I have weigh boats and I have spatulas and I have beakers, if I'm setting them on the mat, it won't electrically charge up, and it'll drain some of the charge off of those things just as it's sitting there. And it also gives us a common area where we know we're not going to be generating, because we slide things across tables all the time. We don't necessarily always pick them up. And so utilizing that mat and having them there, it's just an extra layer of protection. If you weren't going to use the mat, you didn't want to use the mat, I would still recommend using a wrist strap and plugging it directly into an outlet using a grounding system. But if we're doing very precise measurements, I try to do a holistic approach to it, and that's just one extra thing that you can do to help guarantee repeatability.
One of our attendees writes, when I weigh carbon powder, it sticks on the weighing paper. How do I remove the static charge from the carbon powder?
The trick here would be to remove the static charge from the weigh paper prior to using it, because as soon as you pull the weigh paper out, it's charged. So I would take the weigh paper, hold it in front of the fan, put it in front of the ionizing bar, set it on the weigh pan, so we know there's no static there. Now, as I go to remove my powder, my carbon powder from its container, I would want to do that in the presence of either a alpha ionizing source, such as a BF1, or an ionizing bar, so that as I'm pulling the powder out, it tends to want to charge. So I'm going to do that in the presence of an ionized field, an ionized air field. So I don't have static on the powder as well. And as I transfer it to my paper, if I could transfer it in front of an ionizer, again, another layer of trying to remove that, because as you pour it, the individual little grains of powder all have static on them. It's a surface charge. So if I can do the transfer process in the presence of an ionizer, that also will help mitigate any of that electrostatic charging on either of those two materials. So we got to look at both the process of how we're transferring the powder and the weigh paper itself to make sure it is also static free. So you always have to have that holistic approach, look at all the different components.
All right, thanks, Greg. Next is, if I am only using an outside balance ionizing device, would it help to pass the metal pan from the balance through the ionizer?
The metal pan, typically will not have a charge on it itself until we introduce an electrostatic charge to the area. So let's say that the walls of my balance have static charge on them. I take the pan out, put it in front of an ionizer, it's static free. The moment I put it back in the chamber, it's going to be influenced by the static charge on the walls. It's going to be influenced by static charge on anything I put in there. So the better solution is use an ionizing blower or an ionizing brush to make sure you have no static on the walls of the weigh chamber, and then make sure you have static taken off anything that you're introducing onto it, and then the weigh pan itself will be a non-factor.
Okay, great. Next up, what type of solution would you suggest for scales that are open air, for example, analytical, and are sitting on a bench top? Will the product demonstrated in the slides work for open air benchtop scales?
Yes, all of the products, all the different solutions you've seen are all effective, whether you have a draft chamber or not. All those scales, even if it's open air, it's going to be influenced by charge on the sample itself. So again, using the different techniques on the material, the transfer mechanism, whether it's a vial or a beaker, prior to putting it on there is going to increase your accuracy. All the things we do with static control, there's no silver bullet that makes it perfect. We're trying to remove as much of the variables as we can and getting as close to the perfect thing that we can. And so that's why we use these different solutions. But yes, it will work fine with an open air balance.
All right, Greg. Is a single pass through or near an anti-static device typically sufficient to remove any static charge?
Yes. Yes. If you're, again, everything's a matter of degree. I mean, if I take my time moving in front of it, moving it through the ionizing field, now it depends on the type of ionizer you're using. If you're using a bar ionizer, it's got a very strong field that goes very far. That's very good. If you're using one of the, I call more of a passive one, such as the alpha ionizing cartridge, that one you have to bring it closer to it and hesitate for just a moment before you move past it.
Very good. What's the big difference between these Ion Master products and a common ionizing air purifier? Will an air purifier work as a quick solution until a proper device can be purchased?
An air purifier will not work for this particular application. What it is doing inside the purifier itself, there's two different stages to it. In one stage, it's putting a charge on the dust particles in the air as it enters into the device. In the second stage, the collection stage, it puts the opposite charge on metal fins or different parts. So again, opposites attract. What it's going to do is it's going to take all that dust and particulate and it's going to coat the inside of that collection chamber. But what comes out of it is not ionized air. It's just meant to take impurities out of the air. So you have very clean air in the area, but it doesn't produce the types of ions that we want to do with this type of static removal.
If an ionizing blower is being used to remove static from gloves while weighing samples, is there still a need for the workstation kit to remove static from the technician?
It's more than just the gloves. So again, it's a matter of degree. I have the blower, takes it off my hands. Do I have a smock on? What's my smock made out of? Am I wearing a wrist strap? Because on a dry day, I walk across the floor, I sit down at the bench, I might have 8,000 volts of static charge on me, I don't even know it. So that's in addition to the gloves. So it's, in this case, if you want the best solution, I would use the blower for the gloves. I would have a wrist strap and have that connected to ground. And I think that would do a great job for you. You don't have to have the complete ESD station.
All right. I have a density determination accessory kit I put into the balance. I see the imbalance ionizer is low center of the balance chamber. Could it be mounted higher to keep it out of the way of the density kit?
Yes, yes. The internal ionizers in the balance, such as let's see if I can find the picture real quick. So this type of, if you're using this type of an ionizer, they're real simple, very effective. You can position it anywhere you would like in the back of the ionizer. You could even position it on the top if you prefer. The thing to remember is that it's got a small ion cloud about the size of a ping pong ball, a tangerine. So you have to bring what you're doing up to it. If you think that you can mount it on the top and it's going to ionize the entire chamber, they're just not strong enough for that. Our company in particular, we're working on a new type of ionizer that could be mounted inside the balance that will eventually ionize the entire chamber. We're not there yet, but that is on our drawing board. But to directly answer that question, you can position that ionizer anywhere you'd like in the balance. Just remember that you have localized ionization.
Greg, are there devices available to measure the level of static charge on items prior to static charge removal and weighing?
There are, and I apologize for not including that in this presentation. NRD manufactures a device. There's other ones available out in the marketplace. It's called an electrostatic field meter. But it is meant for measuring charges on larger surfaces. The smallest object it can measure is a 4-inch square. If you want to do very small items, there's another type that we don't provide, but there's a company out there, I believe the company name is Trek, T-R-E-K. The other one is Monroe Electronics, and they make non-contact electrostatic voltmeters. Those are meant to measure static charges on very small areas, maybe 1-inch square. You have to have the right tool for the measurement. If you try to use a large field meter on a small sample, it's going to average the background, that 4-inch square, and you're going to get erroneous readings. If you just want a ballpark, do I have static, don't I have static, you might be able to get away with it. You're not going to have any meaning from the numbers, but it would tell you if there's static charge there. But the appropriate tool I would recommend. These meters run anywhere from $400 upwards to $1,000, so you'd have to search around for which one best suits your needs.
Next question, Greg, is do you find areas such as pharmacy clean rooms increase the problem compared to a normal lab environment?
The situation that you typically encounter in clean rooms is that the atmosphere is conditioned. They tend to be drier. There's less humidity in them. And so if you have less humidity in the air, charge generation becomes a bigger problem. And so in many clean rooms, you're going to find more static charge generation than, say, in an open area on a manufacturing floor or a general laboratory environment where the humidity rises and falls depending on the time of the year. So, yeah, in some cases, you're going to see more static charge easily generated.
Greg, is there any risk of shock using any of these control devices?
No. There are devices out there that you might have to be careful about. The Alpha line of products, they don't have power. They don't need power to work, so they're actually considered intrinsically safe and for static removal on volatile and flammable materials. They can't generate a spark. The electrical ionizer that we use, that we offer, is what we call shockless. So unless it's improperly hooked up, someone forgets to connect the green ground wire, it is shockless. So you can touch it, you can hold it. There's no shock from it. So there shouldn't be any concern about that. I can't speak for other people's products.
Which device would be recommended for a one-time purchase for a balance that has multiple users?
Well, I like the simplicity of the alpha ionizers. They're easy to use, but the downside is they do have to be changed out. Maximum effective life is probably around 18 to 24 months on those. So that is something that if you love what it's doing, you're going to have to recognize you're going to have to replace them, every year and a half or so. An electrical bar ionizer, it should give you a good 5 to 7 years of life out of it. So the first cost is going to be higher because you got a power supply and it's a little more involved. But it will, if taken care of, it'll give you many years of good service, and it can be used in almost all applications. The only place it's not going to help you is if you start building up static charge. If you're using a draft shield, if you're using that type of a chamber, it's not going to help you with that. You're going to need a secondary solution for that. And having a field meter would tell you if you charge up on your glass. But if you see particulate accumulating on the inside of your chamber on the walls, you've got static charge on there. So you might need a secondary tool, something as simple as an ionizing brush if you wanted to keep the chamber clean.
Can nearby instrumentation within a lab cause static problems beyond what's already been discussed?
I'm not sure I caught the question. Can nearby instrumentation static problems?
Right, instruments nearby within a.
Some equipment can generate, and I am not an electrical engineer, but I'm familiar with the subject. There's electromagnetic interference, and these EMI waves sometimes will cause problems in the electronics of the scale. But what you wouldn't see an inaccurate reading. What would happen is all of a sudden, if you have a higher end scale, it's going to lock up. It's for whatever reason it's not operating, and you have to turn it off and turn it back on again. But it won't induce static charge on different materials and things like that.
What's the lifespan of the static dissipated mat? Is it standard or?
The static dissipative mats last many, many years, again, as long as they're taken care of. If you start accumulating a lot of dirt, you spill stuff on it, it starts breaking down the conductivity of the surface, and it stops performing its function. People who want to clean them with caustics and Windex and different things like that, 409, you destroy the surface integrity. The most you could do is you wipe them down with a wet cloth. So if they're taken care of, you have years and years of use. This is more of a general application for it, where it's not as critical as people who typically use them with very sensitive electronics. And there, you really have to make sure that they're performing their intended purpose to the highest degree. In this particular application, if you take good general care of it, it should last you for many years.
We have about 6 more questions, Greg. Next one up is, how would you eliminate static charge from a weigh pan?
From the weigh pan itself? Again, the weigh pan itself is always going to have its charge induced on it. That means there's something that's come in contact or near it that's causing it to charge. So the only way to eliminate the charge from that is to eliminate the source. So if I am sure that I've taken the static off my weigh boats, my beakers, my samples, I don't have static charge on my draft shield, then you won't have a static charge in the weigh pan. If you know that you've got static charge on all these different devices, all these different surfaces, you take all the charge off of all those things first, then you lift off your weigh pan and you hold it in front of an ionizing blower or an ionizing cartridge, or you pass it through your I-beam, your static bar, and that's your very last step. Once you've removed all the other sources of static, because in the weigh pan. It's being induced in the pan from something else. So it would be the last step you do after you're sure you've eliminated all the other sources of static charging.
Under what conditions does it make sense to use a bar ionizer instead of a fan ionizer?
The bar ionizer can be used for a multitude of applications. The only reason I like to include it in a presentation is it does have some ease of use type applications. If I'm using test tubes, if I'm using glass beakers, those types of things where I have an internal as well as external dimension, it's really quick and easy to ionize the inside and the outside. And if you know that I've really penetrated into something that's, say, narrow and deeper using a blower. And in addition to that, if I have concern about static charge inside the balance itself on the walls on the pan, I can simply pick up that blower and blow ionized air over the outside and inside of the weigh chamber before I begin working. So it's not necessary. It's just another tool. We like to have a lot of different tools on our tool belt, depending on what we come across. But each individual application and situation is unique, and you pick the best tools for what you normally see on a day-to-day operation.
I think we have time for one more question here. Greg, what is the best method to remove a static charge from a thermal gravimetric analyzer balance and chamber?
I have to apologize. I am not familiar with that particular piece of equipment, but if the concern is that there's static charges within it, there are devices that can be mounted within it, assuming what the temperature ranges are. Our alpha ionizing cartridges can handle, I'm thinking it's 160 degrees C. So if it goes beyond that, you're not going to want to put an ionizer inside the chamber. And then it depends on the size of the chamber that you're trying to ionize. If it's basically a metal container, a metal chamber, it's probably grounded through the equipment. So now it's about taking the static charge off of whatever you're trying to do before you enter it into the chamber. And then it would depend on whether it's powder or if it's an object, it's a mass. If it's a mass, you can use a blower or you can use a bar. If it's a powder, you probably want to use a bar. So if there are specifics where it's difficult in this forum, please feel free to contact us via email, phone call, whatever you want, and we can discuss your individual applications in greater detail. So try to do our best in this particular forum, but we're always available. We have technicians always here to help you with your specific applications.
Thanks very much, Greg. I'd like to remind all the attendees that questions that were not addressed directly here will be answered via email, so please look for those. And Greg, thanks again for sharing your knowledge with us. I thought we were going to stump you there today, but that didn't happen. So also like to thank NRD, Advanced Data Control, for sponsoring today's event. And an email containing a link for viewing this webinar on demand will be sent to all attendees. We ask that you please forward it or to anybody that you think may be interested, or show it to your colleagues who you think may have an interest. Once again, thanks very much, everybody. We appreciate your time today.
Thank you very much, everyone. Have a great day.